No.
He's gonna need a salary.
Good morning, Abyssers. What did you say?
He's gonna need a salary for that.
Oh, I'll make it up to him. Yeah, you know. First of all, he'll get virtual extra credit points for sure. What do you got now? 2? Yeah, maybe you haven't. Alrighty, it says, write the integral that determines the area under this curve. Determine that area. That area is considered the sum of the areas of an infinite number of rectangles. You remember that, Landry? Okay. What is the height and area of those rectangles? So let me draw one of those rectangles. It's skinny, isn't it? What's the height of that rectangle? F of x. Very good. And to be exact, it's 0.125 x to the third plus 3. Correct? But f of x works. How wide is it? It's skinny. I wonder if I can make it skinnier. Yeah, what's the width? Okay, it is b minus a over n as n goes to infinity. What did we call that? Wow, you remember more than what I would have remembered my freshman year at Bemidji State. Anybody have an idea what we give that name? Yeah, it is a limit, but in the integral, it looks like this, right? We have, this is a 2, this is a 0. We're going to go from 0 to 2, correct? And it's f of x dx, correct? Right? That's the integral. It's a definite integral, correct? Start at 0, stop at 2. Right? F of x is the height. This means it looks like the letter S, and it means summing up areas of a rectangle. This is the height, right? It says sum up the areas of, this little symbol right here means sum up the areas of all the rectangles from z to 2. How many are there? Infinite number. And because they're infinite number, this is getting really, really thin. So in here, if f of x is the height, what's the width? Not sure. It's dx. Remember we called this delta x? Long, long, long time ago. So the area. To do this, Mr. Krebs, how do you remember f of x in here is 0.125, by the way, is 1/8. Okay. X to the third plus 3. How do we compute the area? We have to find the what? What is the antiderivative? Remember, this is 1/8. Makes it easier. X to what power? Fourth. So I got 1/8 times 1/4, correct? Are you okay with that? 1/32. A very popular measurement at Kruger Welding. Plus what? 3x. Evaluated from 0 to 2, correct? That's how I write that. When I put 0 in there, will I get 0? Okay. So it equals 2 to the 4th, Mr. Krebs. 16. So I get 16 over 32 plus 3 times 2. Would you agree with that? Does that sound right?
Yeah.
Okay, minus 0. Because when I plug 0 in there, I'll get 0, right? What does that give me?
6.5.
6.5. Beautiful. So the area underneath that curve is 6.5. Morgan. Right here, they kind of look the same. Here's what I started with, correct? Here's this one. What do you think? What do you think? You think the areas are equal? Here's the first one. This is the x-axis, by the way. And now it doesn't go all the way down, does it? Has some portion been taken away? Okay. This portion's been taken away. Would you agree? Okay. And that portion that's been taken away has area. Would you agree with this? And I believe if this is 2, yeah, it's 1 this way, it's 2 this way. This rectangle's been taken away. This stuff that's supposed to be in green. How much area is that? 2. That's how much has been taken away, correct? And Mr. Krebs came up that our answer was 6.5. So what do you think the area is here? 4.5. That makes sense, correct? 4.5. Hello? Okay. Austin Jansky, you have a message in the office. So this is a rectangle. Would you agree with that, Morgan?
Yep.
What is its height? Is it still f of x? Or is it shorter than that?
It's short.
It was f of x going from here all the way up, right? So what do you think it is now?
F of x
f of x minus
minus 1.
1. Excellent. Caitlin, what's the width? It's not a trick question.
Well, then still is dx.
It's still dx. So my integral, my rectangles are still going from 0 to 2, correct? Here's f of x minus 1 dx. So the antiderivative, well, this is going to be equal from 0 to 2 of 1/8 x cubed plus 3 minus 1 dx. Here's f of x, here's take away 1. That gives me from 0 to 2 of 1/8 x cubed plus 2 dx. Would you agree with that? So my guess is Josh would say this is still 1/32 x to the 4th, but you would say this is, rather than 3x, you would say that's 2x. Would you agree?
Yeah.
Evaluate from 0 to 2. So I get 1/2, right? I'll get 16 over 32. Everybody okay with that? 16 over 32 plus 4 minus 0. Sure enough, we get 4.5. Are we okay? Next page. Allison, it's bigger. Here's the x-axis. I added something on this time, didn't I? This is how much more I added. What is that? And notice it makes a little rectangle. How much area is that?
0.5.
Well, it's 0.5 this way. It's 2 this way, right? Because it's a rectangle. So how much is that? 1. So right here, Mr. Krebs said this is 6.5, correct? Remember from the very first one? And now we're going to add one more, aren't we? So we should get what for an area?
7.5.
We better get 7.5. Because we're adding, correct? So this now is my rectangle, isn't it? It's still skinny. What's my height? Okay, in fact, I'm going to do this. I'm going to write f of x minus a negative 0.5, which is the same as f of x plus 0.5. Correct? Because subtracting a negative is equal to 0.5. You know how I learned that? I was in 4th grade. You know how my teacher, Mr. Hutable, and Mr. Hutable, there are certain teachers I've had that walk on water, okay, that can go through a brick wall. They're like super people, okay? He told me the most ridiculous thing in the world. You know how that's positive? This is a person, male or female, doesn't matter, diving into a pool of cement. And what happens? They get stuck. Thus, it's positive. Totally non-math. And what's even stupider? I remember that. You guys have a nice day.